Hello guys, welcome to a new video. Today I'm gonna enter the world of arrays, lists and maps of Java. This video belongs to a playlist of the complete course of Java for beginners, with no initial knowledge. So, ready for learn Java? Ready to master Java? Take your time to subscribe to the channel and let's start. First, you can find the project I will use in this video at GitHub. You can find the link in the video's description. Clone it if you want to follow the video and test with the exercises. Let's start with the basics. Let's start with the arrays in Java. An array is like a matrix, a vector, a row. It starts with the square brackets, indicating that it will accept multiple values from this type, integer. It's instantiated as the object, with the new keyword. Then the type, then the square brackets, and between the curly brackets, the initial values. As instantiating an object, you need the new keyword. Nevertheless, the arrays work with all kinds of data, the object and the primitives, which is this case. But there is another way to write it. This way you avoid the new keyword and the type. The type is already inferred from the data you have inside the curly brackets. And do you remember the var keyword from Java 10? You can also use it here. But here you need the new keyword and the type to be explicitly written. Okay, that's the initialization. And to read it, specify the index of the value you want between the brackets. But be aware that you are in a zero-based index. The first element is 0 and not 1, as in this case I obtain 8, which is the second element. Specifying the index between the square brackets, the rest acts like a common variable. It can be used everywhere, in calculation, input methods, output methods. You can assign back a value to another method, and the resulting will be the type without the array, without the dimensional specification. After applying the index, the resulting value is an integer, a common integer. You can even replace the value, as with a common variable, setting a new value. Then the value in the array will be replaced. I got 10, which is the new value I set in the index 0, in the first element. But what is this used for? Why do we use the arrays? The arrays are mainly used for calculation, because there is very low level without any requirement from Java, so it can speed up faster than with objects. But another case is for strings. Do you remember them? The strings are a chain of characters. Sometimes you start with a string, but you want to look for a single character in the string. Okay, you already have a method for that, but let's see another case. Then you can search for a single character and replace it, or you can even check the length of the array. Length is a property, not a method. As you see, there is no parenthesis. It's like a field. It's a property of the array. As I said, the arrays are not specific to primitive types. It's also used with objects, strings or other objects. user is just an object I've created for this exercise, and you can access the values as before. I obtain the first string and the name of the second user. As I said, after using the index, the rest acts like an object, like the user object, so I can read the fields. And now I can go with the multi-dimensional arrays. From this initial vector or row, I can now create a matrix. This means that instead of having an integer at each index, I have an array at each index. As you see, in the index 0, I have an array. It's an internal field, an internal object of Java. That's why I see all this strange identification. But if I specify the second index, I obtain the value. The value of the first row is an array with the values 9, 8, and 7. And the values of the second row is an array with the values 1, 2, 3, and 4. That's not really a matrix, because each row is independent. Each row can have a different size. But that's also a warning. You must check the size before accessing a value, otherwise, exception. Array index out of bound exception. And you can create multi-dimensional arrays of 2 dimensions, 3 or more. I don't think there is a limit. The limit is your imagination. Enough with the arrays? You have some exercises to practice below. Try to do what's asked in the description and run the tests from the test class, which is in the test folder, arrays package, right click, run as JUnit test. Turn this bar to green. But what's the limitation of an array? The arrays have a fixed size. What if I want to add more elements? Or what if I want to remove one element? Here comes the list in Java. The list is like an array. In fact, the most used list is based on arrays, is the ArrayList. I will only speak about the ArrayList of Java in this video. Ask in the comments if you want some references for other lists. The ArrayList is an object, so as an object it has methods to add an element, to remove an element, to calculate the size, to search for an element, and more. To instantiate an ArrayList, it's like this. You can instantiate it with the var keyword or indicating the ArrayList. You have to specify it's an array list, what kind of content it will contain, then create the new list, instantiate the list with the new keyword, and call the constructor of the array list with the parentheses, and the semicolon at the end. It's harder than we saw before, right? What may disturb you is the user between those symbols, the less than and the greater than. It's called a generic. The array list accepts a generic. It means that it accepts any type of object, but you have to specify the object to work with it properly. I will make a video about the generics later. Let's assume that's a list of users, nothing more. And you have the var keyword here too. Now the generic goes in the right side to let the list know with which object it has to work. In fact, in older versions of Java, you have to specify the generic in both places, in the left side and the right side. Now, only in the left side is mandatory, but if you avoid the left side with the var keyword, it must be in the right side. It must be almost in one side. And now, from this list, I can add elements. there is no limit, and I can check the size of the list, which will change with each addition. Two elements. This time it's not length but size, and this time it's not a property but a method. The arrays are a particular type of Java, but the array lists are objects, regular objects with regular methods. As with the arrays, I can also check for an element at a position. As before, it's zero index based, and if I try to access an element which is outside the limits, exception. As before, index out of bounds. After getting the indexed object, I get a user object, where I can access all the methods or properties of the object. And to remove them, easy. The remove method, also specifying the index, or if I want, I have the clear method, which will remove all the elements. Do you want to go further? I can even search for an element inside the list, to work with it, to get its position, or to remove it. How? With the contains method. Index of, or remove, but specifying an object as input parameter. The important thing here is the way the list will compare an object with another, to know if they are equal or not. In a previous video about the strings, I told you not to compare the strings with the double equal sign, but with the equal method, because the strings are objects, not primitives. So to compare objects, you must use the equals method. By default, all the objects have an equals method. Let's use the user object. I don't have the equals method, but Java created it for me. What do the equals method? It will compare some fields and properties of the object. Will do it correctly for this object? I don't know. So let's create my own equals method. Let's overwrite the equals method to be sure the list will use the mine and not the one Java created for me. If I want to overwrite correctly the method created by Java, I have to use object instead of user. I have first to check if the input is really a user. Then I convert the object into a user. That's some casting operations that we will see in another video. And then check if both my name and the name of the input parameter are equals. This is my name, and this is the name of the input parameter. To be sure I am overriding the equals method, I have the override annotation. If Java indicates no error, it's because I'm really overriding the methods. Let's see now if my list can find the users. In the first case, I use contains with a new object, but with the name Joe, which is already in the list. In the second case, I use index of, which returns me the index of the found user, which also is Joe, which is present in the list. And in the last case, I use contains, but with a user which doesn't exist in the list, which returns me false. Cool, right? The search system is already implemented. I just need to have the correct equals method. Maybe the one created by Java will be enough, but this way I'm sure it will compare the users the correct way. Let's slow down a little bit now. Pause the video, try the exercises you can find below to persist all of this in your brain, and then continue with the maps. And now the last point, the maps. As for the list, I've only talked about the ArrayList. With the maps, I will only talk about the hash maps. If you want some references about other maps, add a comment and I will be glad to guide you. A map is a key value list. I have a list of keys and each key is associated with a value. The key tends to be simple, like a name or an ID, and the associated value is a complex object. Or with a var keyword. The difference now is that the generic has two elements, two classes, the class of the key and the class of the value. As you see, I've used integer and not int, because the integers only accept objects, not primitives. And for each primitive, you have an associated object. It's the same name, but with an uppercase. Integer, boolean, float, double, character. They are called autoboxing. Let's now add some elements to the map. Now I put elements, I put a key value entry. I don't add. I put the user Joe with the key 1000. And I put the user John with the key 1001. And to get it, it's like for the list. This time, it's not an index, but the key. If the key is a string, I must get the value from the key string. This time the key is a string, so to get the value I must specify the key string, though which corresponds to the second element. As with the list, you can change the value or remove it. I can also get the complete list of the keys or the complete list of the values. This way I get all the keys in a list, and this way I get all the values in another list. And of course, I also have the contains method to search for a key or for a value. Contains key. And contains value. Okay. But what's the advantage of having a map over a list? Do you remember the cipher algorithms from the primitive types video? All the bitwise operations over a value? The key is sent to a series of bitwise operations to obtain a hash value. When creating a map, Java will allocate some space in the memory, and each hash will have a specific space allocated. Confused? I start with the key Smith, pass through a hash algorithm, and obtain a value maybe 42. The map already exists. The map already has a space in its memory called 42. So I store the value, the user Joe, in the space called 42. This way, when having 1 million elements, I don't have to check one by one where's the key Smith. The map will compute the hash to obtain the value 42 and go directly to the position 42. And it returns me the user. It looks at no more keys than the one I asked it. It's a lot more efficient for search engines. Google doesn't have a list of all the pages. When asking for a page, Google won't scroll down all the pages until he finds the one you asked. The search engines work with maps, with key value pairs. Here you have some exercises to master the hash maps. When finished, continue with the video for the recap. As for the arrays, both the maps and the lists can have multi-dimensions. You can have a list with lists inside, or a map with maps inside. But the more complexity you add, the more complexity you will need to read the values. So recap, the arrays have fixed size. You can change the values but can't add or remove elements. With the list, you can add, remove or change the values, but they are slow for searches. And with the maps, you can add, remove and change values, the best options for searches. But as you imagine, it will need more resources, more memory and CPU. Now you know how to master the lists of objects. Now you know quite all the kind of data types available in Java. Now you're ready for more flow control for the next video. Click on the like button and subscribe to miss no videos of this course of Java. Bye!